Hi, this is Math Kimchi, and today we will learn about exponents. When something is an exponential form, it is numbers and then a superscript and another number. And the number on the bottom left is called the base, and the number on the top right is called the exponent. And the two numbers together are called the power, or is called the power. And when something looks like this, you say base to the exponent. And what base to the exponent means is base times itself exponent times. And another way of writing base to the exponent is base, then the caret symbol, and then exponent. And usually you will do this way when you're typing. Now let's see some examples of exponents. 2 to the third is 2 times 2 times 2. 2 times itself 3 times, and that is equal to 8. 3 to the fourth is equal to 3 times itself 4 times, so 3 times 3 times 3 times 3, which is 81. 4 to the 2 is equal to 4 times 4, which is 16. And 0 to any positive integer is equal to 0. Now that we know what exponents are and have seen some examples of it, let's try thinking of some exponent rules. First, let's see what a to the x power times a to the y power is equal to. Well, a to the x power times a to the y power is equal to x numbers of a's times y numbers of a times itself. And that is equal to x plus y numbers of a's. And that is equal to a to the x plus y. A to the x divided by a to the y is equal to x numbers of a's divided by y numbers of a's. And when you do that, y numbers of a's cancel out on both the numerator and the denominator, leaving us with x minus y numbers of a's, or a to the x minus y. Now let's look at a to the x to the y. And that is just saying y numbers of x numbers of a's. And that is the same thing as saying there are x times y numbers of a's being multiplied by itself, which is a to the x times y. Negative, and now let's look at negative and 0 exponents. First, 0, when the exponent is 0. To understand this, let's look at a table with a to the x and x. If x is 3, then a to the x is equal to a times a times a. If x is 2, then a to the 2, or a to the x is equal to a to the a, or a times a. And if x is 1, then it is equal to a by itself. Now we can see a pattern where every time we go down by 1, you are dividing by a once. And when you go down by 2, you're dividing by a twice. And another way to say that is when the x value is decreased by y, you divide the original value by a y times. And if instead of doing the table, you wanted to use our rules from earlier, you can use this rule. A to the x divided by a to the y is equal to a to the x minus y. And a to the x is, or a to the 0 is the same thing as a to the 1 minus 1. And a to the 1 minus 1 is equal to a to the 1 divided by a to the 1, which is equal to 1, unless a is equal to 0. And when a is equal to 0, it will usually be undefined. But some calculators say, on some calculators, it says 0 to the 0 is equal to 1. And now let's add this new rule to our exponent rules. And now to look at negative exponents, a to the negative x. Let's say negative x was the exponent, then a to the negative x is the same thing as a to the 0 minus x, and that is equal to 1 divided by a to the x. And when a is 0, it will be undefined, since a to the x, if x is a positive number, will be 0. And 1 divided by 0 is undefined. So let's add this to our exponent rules too. And an important thing to know when you are using these exponent rules is that some of these don't actually work with 0. So you should consider that when you're solving a problem. And for practice, try to find 0 to the second power divided by 0 to the 1. And then find 2/3 to the negative second power. And finally find 80 to the 0 power. And an easy way to check if your answer is correct is just type all of these in on a calculator and see if your answer is right. And that's the end of this video, and thanks for watching. Bye. We will discuss what will happen when exponents are not integers later in another video. Bye. Thanks for watching.